What's up, Algebra 2? We got to learn about long division. So I hope you got some time because it's going to take a while, right? Because it's called long division. So it must take, no, that's not why it's called long division. All right, so let's review how we do this without a calculator. All right, so here we go. The dividend, right? So that's the little den that you make out of this, 672. We're going to divide it. The divisor is 21. So how many times does 21 go into 67? 3 times, right? Because you're thinking, well, 1 would be 21, 2 would be 42, 3 would be 63. So what's happening is you're doing 3 times 21, you got 63. So it goes right here, and then we're going to subtract it. I'm just going to use a minus sign and circle it. You'll see why, because we're going to do this not with regular numbers. We're going to do it with polynomials. Crazy talk. So let's go ahead and subtract. So that's 4, and bring this down to, all right, 42. So it's going to go 2. So then I do 2 times 21 gives me 42, and I subtract and I get 0. So the remainder is 0. So what's that mean? Right? Awkward silence. What that means is 21 times 32 is going to give you 672 exactly. Right, so that's how we do our long division. Now what we're going to do is we're going to change this out. We're going to use it with polynomials. You see that below. All right, but we have to have that idea of what's happening. So only a couple problems today. We're going to make sure we take our time and you understand what's happening so we can get to where we need to be. Okay, so x plus 5 is out here inside the dividend. Right? So 4x squared plus 23. Well, that wasn't a good start. 23x minus 16. All right, let's do this. Oh, wait, how do I do this? This is completely different, Mr. Rotolo. I have no idea what you're talking about. Excellent. Okay, so out of this whole thing, right, we only care about one thing and one thing only, the very first term and the very first term. That's the only thing you have to worry about. Okay, the rest of it is just going to fall into place. Okay, it's like falling in love. It's going to be super easy. All right, so I have x. I need it to turn into 4x squared. What would you have to multiply it by? Oh, 1, I'd have to multiply by 4. X, I need it to turn into x squared, so I need another one. Well, that means we're going to use 4x. So here's what happens, right? I'm going to take 4x times x plus 5. I'm going to put that thing right in this line here. So 4x squared plus 20x and subtract. Okay, I could do this. Let's subtract 4x squared minus 4x squared. They have been eliminated, right? That's what I mean. We're going to deal with one term at a time, and we're going to try and get rid of it as best we can until we can't do anything else with it. 23 minus, don't forget to stop over here. 23 minus 20 is 3x. I'm going to bring this down, minus 16. All right, now I still have x, and I need to turn it into 3x. What are you going to multiply by? I hope you said 3. So positive 3. So 3 times x plus 5. I'm going to distribute this and put the answer right here. 3x plus 15. What do I do with my long division? I always subtract. 3x minus 3x. Got rid of it. Yes, that's what we need to do each and every time. Negative 16 minus 15 is negative 31. Well, if I have x, I can't turn it into negative 31, so that means we're done. That would be the remainder. Okay, so that would be my remainder. How do I write my remainder? I've never done this before. Now what you do is you take plus, take this remainder, negative 31, and put it over top of what we're dividing by, x plus 5. Okay, so this is the way we want to see this answer written out. What's that answer mean? Well, what it really means is if I asked you to FOIL, I know you can. Don't give me that look. I know you can FOIL, right? If you took x plus 5 and you multiplied it by 4x plus 3, and you added negative 31, you would get the dividend in here. Okay, so we'll show you that as the remainder theorem, but I just want to try and tie that together based on what we did up here. Remainder was 0. Okay, so what it really means is these two multiplied together doesn't exactly give me that. So that means it's not going to be a factor as we look at x plus 5. Now let's try it again. What's the quotient and remainder? Okay, so I have an idea that maybe I should get a remainder, but maybe they're trying to throw me off. Maybe the remainder is 0. All right, let's just work on the problem. X minus 7, 3x squared minus 29x plus 56. Man, 3s, 29s, 56s. I don't know. This seems like a lot of work. I'm going to go see the nurse. I don't know. I'm just kidding. You can do this. Remember, I only care about one term at a time. The rest of it just falls into place. So if I have x, I need it to be 3x squared. I need another 3x. So 3x times x minus 7. We're going to put that in the second line. Here we go. Distribute 3x squared. That means I did something right. Distribute negative 21x. All right. And subtract. Ooh, whoa, whoa. Look at this. Negative 29 minus negative, right? So that means I have double negative. So it's really negative 29 plus 21. Okay, so that's what, negative 8 on the x's plus 56. Remember the new item in front here, I only care about the first term, is negative 8x. We already have x, so I just have to multiply by negative 8. So negative 8 I'll put up top here. All right, so negative 8 times x minus 7. Let's distribute it. Negative 8x plus 56. We're going to subtract. There it goes. And 56 minus 56. There it goes. My remainder is 0, so I don't have to write anything extra up here. And what that means, and we could go over here and say x minus 7 times 3x minus 8. If I said, hey guys, let's FOIL this together, what do you think you're going to get? Take a wild guess. Bum, bum, bum. 3x squared minus 29x plus 56. You betcha. Okay, so we have a way to check these by dealing with the result. Okay, so here's that remainder theorem that I pointed out before. If it did have a remainder, we just add that thing on to the end, right? And I double signed it before, so add negative 31. Okay, it just makes it a lot easier to realize what we're going to do. So just realize I'm always going to add on a remainder, and then if it's negative, you add the negative. We can do that. Okay, so that means I want to multiply right, the divisor and the quotient, and then I add on the remainder, and then I can figure out if I did it correctly. So automatically a way to check it all the time. I love it we can check things all the time, because if I can check it all the time, then I can get it right all the time. And I like getting things right. See? All right, I'll just move on. I know we got one more, and then we'll make a completely separate video lesson on synthetic division. All right, whoa, 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 what's going on here? I got x squared plus 1. X squared plus 1. Right, see, over here in the divisor, that's okay. In the dividend, since I don't have an x to the first power, that's not okay. Because this is all based on spacing, kind of like the decimal system. So as I fill this one in, all right, 3x to the 4th minus 4x to the 3rd plus 12x squared, but I don't have an x to the 1st. So how many x to the 1st do I have? 0 x to the 1st and then plus 5. Now I need this in the dividend because everything is based on spacing. Okay, so let's see what happens and see if, right, if I get no remainder, then my answer to this is yes, it is a factor. If I get a remainder, then it's like, nah, not going to happen. Okay, so again, one term at a time, even though there's a lot of terms in this one, and we even added one in there. We're trying to make this easier. All right, I get x squared. I need to be 3x to the 4th. I'm going to multiply by 3. And I need 2 more x's. All right, so here we go. Let's shrink this down a little bit. So I need 3x squared times x squared plus 1. I'm going to put that in this line. 3x to the 4th plus, whoa, 3x squared. Now I do want to line up my like terms and subtract. So we're going to get rid of these and bring down this one because negative 4x cubed minus nothing is negative 4x cubed. 12x squared minus 3x squared, well, that's 9x squared plus 0x plus 5. I'm just going to bring everybody down to the party so I don't forget about something later. But I only have one term in the beginning, and here it is. I have x squared. I want it to be, you do too, negative 4x cubed. So I need negative 4 and another x. So negative 4x times x squared plus 1 distribute negative 4x cubed. And we're going to get minus 4x. Again, leaving that space in there. We have to subtract double negatives. We cancel out our 4x cubed. Bring this down, 9x squared. What's 0 minus negative? That means plus 4. So plus 4x plus 5. All right, one more time. My lead term is 9x squared. I have x squared. I need to multiply it by, you guessed it, 9. So 9 times x squared plus 1, distribute. Put that answer under here, 9x squared plus 9, and subtract one last time. There it goes. 4x minus nothing is 4x. 5 minus 9 is negative 4. This is my remainder. Okay, so this one says, is it a factor? Since I have a remainder, my answer is no. How do I write it? Well, that's a good question. So I go plus, put the remainder in the numerator, 4x minus 4. And what were we dividing by? X squared plus 1 goes in the denominator. Okay, so that means if I were to multiply 3x squared minus 4x plus 9 by x squared plus 1, I would still have to add on 4x minus 4 to get this original problem that we started with. Okay, so we're just doing some multiplication, division, right? You know they're intertwined, working those backwards. But now with polynomials, same thing, guys, same thing. All right, so that's our long division, and I'll see you next time.